Hello everyone, my name is Vamsi Pitta. I'm a solutions architect at Amazon Web Services. In this video, I'll walk you through the process of migrating a PostgreSQL database from Google Cloud SQL to Amazon Aurora PostgreSQL. Let's get started. Here, I've created a sample PostgreSQL database of version 16.8, which I'm calling it as source. I have enabled a public IP connectivity for this instance, which is going to be a key part in our migration. Let's open Cloud Shell to check the sample data. I've created a sample database within the instance for a periodic table data. Connect to the database, provide the password. Let's run a select command to view the sample data. Here is a sample data which we'll be using for the demo. Let's exit out from here. To enable replication, we have to set a couple of flags for this instance on GCP. Let's click on Edit Configuration on the console. You scroll down to the flag section. Let's add a database flag. First, we have to enable logical replication. Search for logical decoding. Set the flag, add another flag, and search for PG logical. Select enable PG logical. Once you add those two flags, scroll down to click on save. Click on save and restart. While this is happening, let's switch to AWS console. Over here, let's start by understanding the VPC layout. In my account, I have a custom VPC with two subnets, two private subnets and two public subnets. In this demo, I'll be using the private subnets for creating the Aurora instance, and I have a couple of security groups. One is called private server security group with inbound rules allowing communication from the internet facing security group. Also, I have an internet facing security group with inbound rules allowing communication from the internet. All right, so let's go to RDS. Before creating a database instance, since we'll be migrating from a different database, we'll have to create a custom parameter group. Let's go to parameter group. I have a sample here. I'll create another a custom parameter group. Let's provide a name and description. We'll select PostgreSQL as the engine, and we are dealing with version 16 in this demo. And this is going to be a cluster parameter group rather than a database parameter group. Let's go ahead and create. Once it's created, go to the parameter group and click on edit. Search for logical replication. So set the flag to 1 and search for sender timeout. So you'll see nothing here, set it to 0. So with those two, save those changes. Let's make sure it's updated. So I have sender timeout as 0 and logical replication as 1. Okay, so this should be it. We are ready to go ahead and create an instance. Let's create a database. Aurora PostgreSQL is pre-selected. Let's do a standard create. For the version, let's leave the selected major version here. And since this is a demo, I'll be selecting a dev test template. Let's call it target PostgreSQL DB. And we'll use AWS Secrets Manager for managing the credentials. For instance configuration, let's use burstable class and we'll use T3 medium for the demo. I'm not going to choose to create an Aurora replica just for the demo, but for production workloads, it's highly recommended to use multi-AZ deployment option. As you can see here, custom VPC is pre-selected and there is a DB subnet group as well. The key thing here is let's make sure public access is selected as no, since we want the database to be private, and we'll use a Cloud Shell to privately connect to the RDS for verifying the data. Okay. For the security group, as shown earlier, let's select private SG and we can uncheck the default. So everything else should be okay to go ahead, except there is one last thing that we need to do here, which is choosing our custom parameter group. So PGSQL custom parameter group is the one I just created. So let's select that, and it has both of those flags enabled. Everything else should be good to go. Let's go ahead and create the database. While this is happening, we are good to go ahead and create a DMS replication instance. We'll be using AWS Database Migration Service for this demo. Uh, there are few things here we'll be creating. One is a database replication instance, and we'll create endpoints for the source and target. And finally, we'll create a task for the actual migration. So let's start by creating a replication instance. Click on Create Replication Instance. I'll provide a name. We'll leave the instance class as T3 medium. High availability, let's select dev or test for the demo. For network connectivity, let's select the custom VPC, and I'm going to select the subnet group which is created for the DMS. This subnet group is nothing but a collection of all subnets within the VPC, and I'm going to select publicly accessible as true. This is very key in this case, because when you create a publicly accessible DMS replication instance, DMS will provide a public IP address which we will go back to GCP console and add it to the connections for allowing the connection. Everything else should be good to go. Let's have one final look. We have a name, we have the instance class, a tester or dev type of workload, and then publicly accessible instance within the custom VPC. Let's click on create replication instance. The replication instance is now ready. Let's click on view details to copy the public IP address. Let's go back to GCP console. We don't need the Cloud Shell at the moment. Let's close it out. Now we have to allow the public IP address to be able to communicate with this Cloud SQL instance. For that, let's go to connections, click on networking, and add a network. I'm going to call it as AWS DMS replication instance. Click on save. Now this should allow communications coming from DMS. We'll test it here in a bit. Let's go back to DMS again. Now step one is creating a replication instance. Now the next step is creating the source and target endpoints. Let's go ahead and do that. Click on create an endpoint. First we'll start by creating a source endpoint. I'm going to call it source Cloud SQL endpoint. Just select a regular PostgreSQL. And we'll provide access information manually. So for server name, it's going to be the IP address. So let's copy that. So click on the public, yep, copy the public IP address, paste it over here. Port is standard 5432 and username, Postgres. Provided the password as well. Database name is a periodic table. Right, that should be it for the access information. We have the public IP address, port, username, password, and the database name. Let's click on create endpoint. We'll test these endpoints here in a bit after creating both of them. This time let's create a target endpoint. It's going to be our Aurora identifier and the credentials accordingly. So for that, let's open up RDS console, a separate window. Let's click on the DB identifier. Let's copy the endpoint here. Provide a name of the endpoint. It's going to be endpoint. Engine is Aurora PostgreSQL. Same, let's provide the access information manually. Paste the endpoint that we just copied from previous step. Port is 5432. Credentials, username is Postgres, but the password we have to get it from the secrets manager since we selected that option while creating the DB instance. So let's go to secrets manager. Select the secret name and you can retrieve the secret value from here, copy the password and then paste it back in the endpoint creation step. Let's provide the database name. It's the same periodic table again and click on create endpoint. All right, so now um, we have all steps ready to test the endpoints. However, we still have to create the database inside the target, which is the Amazon Aurora instance. So for that, let's click on Cloud Shell. We'll go ahead and create a VPC environment. So provide a name. And I'll select the same VPC we have been using for the demo. For the subnet, let's place this in a private subnet. Pick any of the private subnets. The security group, I'm going to select internet facing security group. The reason is I have inbound rules for the private server security group, which is tagged to Aurora instance to allow communications coming from internet facing security group. So the VPC environment which we are just creating for Cloud Shell will have internet facing SG and Aurora will have a private server SG. By default, the pSQL version within Cloud Shell environment may not match with your target. So let's check the version right now. Yep, this is currently pointing to the major version 15, but our target is major version 16. So let's go ahead and remove this and install pSQL 16. Going to use DNF commands for that. Let's clear the cache. Install 16. Let's make sure the new version is 16. All right, we should be good to move forward. Right now, let's log into our Aurora database instance and we'll create a new database for the periodic table. Let's do pSQL and provide a host name. All right, so that's the host name. We have the username. I'm going to paste the password from the secrets manager again. Create the database and verify the list of the existing databases. All right, as you can see, there is a periodic table database in here. Right now it's empty. We just created. Let's go ahead and test the endpoints. I'll start with the source. Click on the source and click on test connection. Run the test. The test is successful. Similarly, let's go back to the target and click on test connection. This is also successful. Now we are good to go ahead and create a migration task. Let's provide a task identifier. I'm going to call it Cloud SQL to an Aurora migration. Select the same replication instance. We have the source, database endpoint, and the target. Now, for the demo, I'm going to just do a full load and choose the migrate option. You can also select migrate and replicate option if you need a full load and continuous replication between source and target. For the task settings, um, let's select full LOB mode and we'll leave everything else as it is. I'm going to turn on CloudWatch logs in case if I get errors, I'll be able to go to CloudWatch log group and check the logs. Now for table mappings, let's click on add a new selection rule. Going to enter a schema and I'm gonna enter public here. So the idea is to copy over anything that's in public schema, all the tables within the public schema. All right, so we can do a pre-migration assessment and we'll choose a bucket to copy over um, the results. Let's click on Browse S3. I'll choose a sample bucket that I have for DMS. You can choose to create a new IAM role or use an existing one. I do have an existing IAM role which I'm going to use. We'll leave everything else as it is. Go ahead and create a database migration task. Once the task is created, let's click on View Pre-Migration Assessment. We have a warning and there are a few tests that's passed and skipped. So let's go ahead and view the results. So here you can check what has been skipped and which all are passed. We also check the warning, that is the unsupported data types. So here, using this data, you can go back to the source and fix anything that you want to correct, and then you can rerun pre-migration assessments multiple times until you reach a steady state. Now I'm good to go ahead with this result. I'm going to click on actions and say restart or resume. You should see the task status as load complete. Depending on the size of the data you have, the time to complete will differ. Now we can also check the table statistics here. In my case, 118 rows were copied over from the source. Like I said, depending on the size of the data, it might take a different time for each use case. We can also verify the data that's copied over using Cloud Shell. Let's select our database here, periodic table. Let's do a select command to view the sample data. Yeah, as you can see, we have verified the data that's copied over from the source, and we have used database migration service to successfully copy data from Google Cloud SQL, PostgreSQL engine over to Amazon Aurora PostgreSQL.